Hi everyone, today starts our first look at real-world Vertex applications. So up till now we've really focused mostly on calculating the Vertex as it related to graphing, skills only. So today we're going to start learning how this applies to the real world, which is the most important part. How do we actually use this in life? So for Vertex, let's just jot a quick note. How do I calculate the Vertex given standard form? So standard form is if I was given f of x equals ax squared plus bx plus c, then to calculate the vertex, the x value of the vertex is negative b over 2a. So I'm going to put that there just to remind ourselves of that prior knowledge. It's going to be important for us moving forward. Number 1 says volcanic eruptions can eject lava hundreds of feet into the air, creating spectacular but dangerous lava fountains. As the lava cools and hardens, it may accumulate to form the cone shape of a volcano. The highest recorded lava fountain occurred during a 1959 eruption at Kilauea Iki crater in Hawaii. The graph models the height of a typical lava fragment in the fountain while the fragment was in the air. And if we notice here, here's our graph, and clearly we can see this parabolic shape, indicating that we can model it using a quadratic equation. So let's take a look at our first questions here. First, we're asked to estimate the vertex from the graph. It says, estimate the lava fragment's maximum height above the ground. So take a second and look at this graph, and please indicate where's the maximum height. I'm hoping we are drawn to this point right here as the maximum. And it says estimate. So estimate means a guess. So if we had to guess, I'm looking at my x value, 8, 9, maybe that's 10. So let's make a note. 10, comma, and then when I come up, let's see what we're counting by. If this is 400, this is 200. So we're counting by 200. So 2, 4, 6, 8, 10, 12, 14, 16. Here's 1800, but if I look, it's not really on that line. It's like halfway in between. So maybe 1900? With a question mark? Again, we're estimating. So our estimation is 10, 1900. And when we're talking about this maximum, we are really talking about the vertex, because the maximum or minimum point for any parabola will be the vertex. We have an ordered pair, but we haven't actually answered the question yet. It said, estimate the lava fragment's maximum height. To know how to do that, how do I get the right information from this ordered pair? It's key to look at how the variables are defined. So if I come back here, here's x and here's y. On the x-axis, what do we have going on? What label do we see here? I see time. So I know that this, let's see, time is being measured in seconds. So this is seconds. And then when I look at the y values here, what label do you see there? And I see height, and it says measured in feet. So I know that this means feet. Because we are talking about the vertex, I know that this ordered pair is the answer to maximum height and how long was the lava in the air. So now that we have been able to understand what the vertex means, I can say max height (1900 feet), and I'll put a question mark because it's an estimate, and then how long was the lava fragment in the air? It was in the air for 10 seconds before it reached that height. So And again, we'll put a question mark because that's an estimation. So now how do we put into words what we just did? Because B says, how did you use the graph to answer part A? Is it accurate? So how did we get this point? If you had to put it into your own words, how you identified this point on the graph, what would you say? Something along the lines of looked for the highest point on the graph to find the vertex. Any sentence or idea that conveys this concept would be a great answer for part B. We looked for the highest point on the graph to find the vertex. Now, the other question was, is it accurate? And if I look way back up here at part A, we were dealing with an estimation. So at best, this is a guess. Not accurate. Was an estimate, or a guess, whichever word you would like to use. So we're estimating, hence all these question marks, question mark, question mark, question mark, question mark. So we are not accurate yet. To get more accurate, let's see what prior knowledge we're going to connect to this question. Part C says, writing vertical velocity models. Ooh, this should ring a bell. It's estimated that lava has an initial vertical velocity of 350 feet per second. Write the model for the height, h of t in feet, of the lava t seconds after being projected from the ground. So bringing our knowledge back from the first half of Unit 6, what is the velocity real-world model? See if you can beat me in writing it down. H of t equals negative 16 t squared plus v naught t plus h naught. So recall, this is set because we're on planet Earth. So for as long as we're on Earth, the negative 16 does not change. We need to identify velocity and initial height. If you need some help remembering, you can label these initial height and velocity. So reading for information, do you see velocity? Well, estimated lava initial, oh look, check it out, initial vertical velocity of 350, so that's v naught. So we can start writing the model. H of t equals negative 16 t squared plus 350 t, plugging in velocity. And by the way, if you have a highlighter, you might want to highlight this or put it in a box because it's going to be very important for us moving forward. The last piece we need to decide is initial height. I'm not told a starting height, but if I look at my graph, here I can see that the starting height is at 0, 0, which kind of makes sense because lava starts where? That fountain, what is it called again? Let me see. Yeah, lava fountain. That lava fountain is starting from the ground and shooting upwards into the air. So the initial height of the lava is plus 0. You want to make a note. H naught equals 0 because lava starts at the ground. adding 0 doesn't really change anything. So we can actually simplify this model to be h of t equals negative 16t squared plus 350t. Now that we have our model, notice the connection we're going to make to our prior learning about how to calculate vertex. It says, calculate the vertex, we do know how to do that, and then notice, interpret its meaning. So the question here is, what was the lava's maximum height above the ground, and how long does it take for the lava to reach that height? As soon as you see that word maximum, from now till forever, I'm hoping that when you read that word in your brain, you automatically think calculate vertex. Because recall from what we've done leading up to this, that maximum is the vertex. So whenever you see the word find the maximum, we're really saying calculate vertex. So how do we calculate vertex given this? Well, to calculate the x value of the vertex, we have that awesome little equation, xv equals negative b over 2a. Looking at my model, what's a and what's b? What's a and what's b? I know that this is a, and there's b. So plugging that in, negative b will be negative 350 divided by 2 times negative 16. You definitely need your calculator, so I'm going to take a second and get my calculator out. Please press pause if you need to take out your calculator. So this will be negative 350 divided by negative 32. And then in our calculators, we'll do 350 divided by 32. Notice, I didn't say negative because I know negative divided by negative is a positive. And what do we get? Our calculator says 10.9375, so we can round that to 10.94. Now, what label do I put on this? Notice I'm talking about x. So when I come back up here, look at the graph. What does x represent? Well, I see x is seconds, so maybe I want to keep track of that. Off to the side, x equals seconds, and y equals, what does y equal? Coming up here, y is feet. So even though it didn't tell us here to specifically define variables, that is always a good idea. Because now I know 10.94 is a value for x, and I remember that x is all about seconds. So the label here is seconds. The question, though, said, what was the lava's maximum height? So I actually haven't answered the first question. The second question said, how long does it take? So we answered the second question, but we haven't answered the first question. How am I going to be able to find the maximum height? Let's think about what you have found. So if I were to create a little quick sketch right here, you found that it takes 10.94 seconds for the lava to reach this maximum height. What you don't know is the y value. Well, if I know that this is x, how can I use x to go find y? We can plug it in. So we will be working on h of 10.94. And we'll be using this model right here. So please press pause using this equation here and calculate h of 10.94. When you press play, I will join you in checking your answer. So let's see. We're going to have negative 16 times 10.94 squared plus 350 times 10.94. That gets us negative 16 times, let's see, 10.94 squared. I get 119 point, it says 0.6836. I will choose to round that to 0.68 will work for me. And then 350 times 10.94 is 3,829. Negative 16 times 119.68, I get negative 1,914.88. Adding 3,829 to that, I get 1,914.12, and I know it's feet because we're finding the y value, and I know over here y is feet. So we have now successfully answered both parts of this question. What was the lava's maximum height? 1,914 feet, or 0.12 feet. And then how long does it take for the lava to reach that height? 10.94 seconds. So if we were to summarize part D, and this is important, this was asking us how high. So in big capital letters off to the side, please make a note of that. Whenever we're asked how high, that's going to be all about vertex. Part E asks something different. It says, for how long was the lava in the air? Solve the problem by using the, check it out, quadratic formula. Whenever you hear, or whenever you read something that says, how long was something in the air, you're trying to find, if I draw another picture, don't make it too big because we're going to use this space, make it small. You're trying to find this point right here, because there it's done traveling. So what we're saying is, when is it 0 feet off the ground? Well, it's at 0 feet when it first starts, right here. And then it's at 0 feet again when it's done. That is what it means to set this equation equal to 0. 0 equals negative 16t squared plus 350t. We did this a lot. Set an equation equal to 0 and solve. That always required the quadratic formula. This is our first instance of seeing how this applies to the real world. So when we set it equal to 0, we'll be able to actually find out when is the lava done traveling through the air. Recalling the quadratic formula, I'm going to make a note over here. X equals negative b plus or minus the square root b squared minus 4ac, all divided by 2a. Remember, to use the quadratic formula, the equation has to be set equal to 0. In this case, it was already, which is awesome. So I've got a, I've got b. What's c? What's c? Well, if I remember from before, that initial height was 0. We just chose not to write the 0. But if it helps you, put that back. Or write in a plus 0, because that's what we'll be using for C. Please press pause now and go ahead and work through the quadratic formula on your own. Remember that we set it up where it's like x equals to keep it all nice and neat, draw a line all the way down and keep your equal signs on that line. So here's the quadratic formula. If you needed help remembering it, please press pause and work it all the way through. Let's see if our work matches. So following the quadratic formula, b is 350, so it's going to be negative 350 plus or minus the square root of b squared, which is 350, squared minus 4ac, all divided by 2 times a, which in this case is a negative 16. That becomes negative 350 plus or minus. Now if I'm very careful, in my calculator I can actually type in this entire number at once, but notice what happens over here. 0 times anything I know is 0. So actually I don't even have to worry about that part. Because this whole thing, this piece right here, 4 times negative 16 times 0, anything times 0 is 0. So I really just have to worry about 350 squared, still under the radical sign. We haven't actually taken the square root yet. We get 122,500. So 122,500 divided by negative 32. Taking the square root of that number, I actually get right back to where I started at 350. I'm now ready to break up into two answers. So it would be negative 350 plus 350, all divided by negative 32, and negative 350 minus 350, all divided by negative 32. Here I get 0 divided by negative 32 is 0. Here we get negative 700. Let's see. Negative 700 divided by negative 32. That's going to be a positive. So I just need to work on 700 divided by 32. And I get 21.875. So let's come back and read the question. For how long was the lava in the air? Again, pay attention to variables. Did we find something for x or for y? We found x, and that's helpful to us because the label on the x-axis is seconds. So the lava is at ground level at 0 seconds, which makes sense because that's where it started from, right? Here's 0, 0, 0. Traveled through the air and was back at 0 after 21.875 seconds. It's a pretty long time for that lava to be in the air. So next to part D, we had written how high. Next to part E, we're going to summarize this in big capital letters by writing how far. So if I'm ever asked how far did something travel, I know that I will be setting it equal to 0 if we're talking about something hitting the ground, unless it's a different given information. But usually if we're talking about something traveling, it's done traveling when it hits the ground. If it was something else, like let's say when does it hit a building at 10 feet, you'd put 10, and then before you could use the quadratic formula, remember this has to be set equal to 0. But big picture, whenever you're asked how far does something travel, the question will tell you what to set this equal to, and then work towards using the quadratic formula. So we have two types of questions on the table right now. How high, that requires calculating the vertex. How far, which requires utilizing the quadratic formula. Let's look at another example. Number 2 says, in terms of a title, find the vertex and interpret its meaning. Let's read. It says, the path that a diver's body takes when they jump from an 8-foot diving board is given by, hey, check it out, it gives me a model. So if you have a highlighter, let's highlight it, or use your pencil, put it in a box. Where x is the horizontal distance in feet from the edge of the diving board, and f of x is the height in feet. So let's add these labels to the graph. X is the horizontal distance. So here's x, horizontal distance from edge of board. The more specific we are, the better we will the easier it will be to understand what does x mean and what does y mean. So x is all about how far you are from the edge of the board. So here, like right here is 0, 0. If you're 0 feet from the edge, it means you're still on the board. And then we have f of x is the height in feet. So this is height of diver, also in feet. This is counting by 2s, so 2, 4, 6, here's 8. So at 0 feet away from the board, the diver is 8 feet in the air. That makes sense because they are standing on an 8-foot diving board, so they haven't actually jumped yet. We are asked to find what is the maximum height of the diver. Again, as soon as I see maximum height, I know that this is going to be a vertex question because it's how high. Do I have to go through all the work of calculating? Well, I see here I'm given the model. So I then ask myself, is this in standard form or is this in vertex form? The answer is vertex form. So let's recall. Vertex form says f of x equals a times x minus h squared plus k, where the vertex is h comma k. So with vertex form, if we know what to look for, we actually get the vertex for free. Looking for h. What do you say h is? If we're thinking 4, I agree, there's h. And what's k? I see plus k on the outside, 14. So my vertex is 4, 14. To be able to interpret the vertex, we have to be clear about our variables. So if I look at the x-axis here, or even just reread, x is the horizontal distance from the edge of the board. I'll summarize that by just saying horizontal distance. And then the y-axis is the height that the diver reaches. So you can think of it as like vertical height or height of diver. So if I'm asked what's the maximum height of the diver, which answers the question? The answer is 14. So I can say with confidence here, 14 feet. So if you look at all of number 2, just take a second to analyze what we've done. There was no math involved, which is pretty cool. So if we know what to look for in a question like this where we're given the vertex form, and if we're asked to find the maximum, which means find the vertex, no math at all. Just know what to look for and where to find it. Moving on to B, it says this same function can be written in standard form. Once again, it gives me the model, so I'm going to put it in a box or highlight it. How many seconds does it take the diver to hit the water? Hit the water. Water is at 0. And I'm hoping that even this action of circling water and saying that this equals 0 is bringing back that prior knowledge of water or ground equaling 0, and then if it gives us the model, we will set it equal to 0. 0 equals negative 0.4x squared plus 3.2x plus 7.6. I now know that I can identify from my prior knowledge skills A, B, C. And to solve this when it's set equal to 0, we will need to use the quadratic formula. So once again, if it helps, I'll put this off to the side. Negative b plus or minus square root of b squared minus 4ac, all divided by 2a. And before I ask you to press pause and solve this, let's just understand again why we need to use quadratic formula here. Here's the diver. Here's 0, which is the water. So if you could actually change this to be a water line if you wanted. I'm asked how long until they hit the water. We're looking for this point right here, when the diver enters the water and they hit the water. So to find that, we set it equal to 0. And to solve when it's equal to 0, we're going to have to use quadratic formula. So at this time, please press pause. Work through the quadratic formula. Don't be intimidated by decimals. That's why we have calculators. So carefully use your calculator. Keep it neat. Make sure all your equal signs stay on one line. And if you need to start a second line, you can do that. Please press pause. So let's see if we match. Setting this up, negative b will be negative 3.2 plus or minus the square root of 3.2 squared minus 4a c, all divided by 2a. So half the work is just making sure our setup is right. If our setup is right, we're much more likely to be able to finish this successfully. So my next line is going to be negative 3.2 plus or minus, let's see, 3.2 squared is 10.24. Negative times a negative is a positive, times a positive is a positive, so I know that's going to be a plus. And then I can, my calculator, I can just do 4 times 0.4 times 7.6, and I get 12.16. All divided by 2 times a negative 0.4 gets me negative 0.8. Adding what's underneath the square root, 10.24 plus 12.16, I get 22.4. Did you get that? Still all over negative 0.8. Notice how I've kept it. The fraction has stayed together from step to step. There's no other simplifying I can do here other than now actually take the square root. So let's take the square root of 22.4. I'm out of space here, so I will start a new line. Negative 3.2 plus or minus. When I take the square root, I got 4.73. So plus or minus 4.73, all divided by negative 0.8. I'm now ready to break it up into my two answers. It's going to be negative 3.2 plus 4.73, all divided by negative 0.8, and negative 3.2 minus 4.73, all divided by negative 0.8. Careful with this, let's do it in pieces. So negative 3.2 plus 4.73 is 1.53 divided by a negative 0.8. I get negative 1.9125 as one of my answers. Coming over here, negative 3.2 minus 4.73, we get negative 7.93 divided by negative 0.8 is 9.9125. So this quadratic formula knowledge is a prior skill, which is why I asked you to pause and work it through on your own. If we got the same answers, fantastic. It meant that we retained that prior knowledge. If we're struggling a little bit, please reach out to me and stay after for some extra practice and I can help you. Let's see how we're going to answer the question. It said, how many seconds does it take for the diver to hit the water? Well, we know we can't have negative time, so we'll reject that answer. And our real world answer is 9.9125 seconds. I'll take just a quick second to highlight the fact and answer the question, why do we have a negative answer? Well, coming over here, even though I only see this real world part, remember, if I were to actually put this into my graphing calculator, this parabola would come down over here. It would keep coming. And this would be a negative x value. But because we're in the real world, we can't have negative time, so this answer doesn't have a meaning in the real world. This one, on the other hand, does, because it's positive time. So for emphasis, just to make it clear, this one was a how far, or how long. You can either say how long, how far. I'll stick with how far. Which told us quadratic formula. No mention whatsoever. No mention of maximum height anywhere. So that's how I know it definitely was not Vertex, if I wasn't sure. Number 3. The archway that forms the ceiling of a tunnel can be modeled by the equation, and check it out, it gave me an equation. How awesome. Where x is the horizontal distance in feet from one wall of a tunnel to the other, and f of x is the height in feet of the ceiling f of x is the height in feet of the ceiling from the floor of the tunnel. So to make sense of that, before we go any farther, let's draw a picture. So we have this tunnel. I'm told x is horizontal distance from one wall of the tunnel to the other. So literally from this wall, this is the start of the wall, to this wall, horizontal distance this way. F of x, or y, is the height of the ceiling. So that's vertical distance. So height of the ceiling, which is like right here, the top, and it says from the floor. So we're talking about this measurement right here, this vertical measurement. Let's read the question. How many feet from the walls of the tunnel, so from the wall, here's the wall, the start of the wall, does the ceiling reach its maximum height? What is the maximum height? Why am I circling those words in red? Because as soon as I see the word maximum, I need to think vertex. Because we're talking how high. So I'm actually going to leave this one for you to work on. The only reminder I'm going to put here is negative b over 2a. And at the start of class tomorrow, we will see what you got for this answer. I'm looking for real-world labels on your answer. So start of class, we'll check answers on this one. And the in-class practice will start here. Notice it says homework, so this will be our in-class practice. The first question being a lighting fixture manufacturer. Great job. So take a couple minutes right now, please, and wrap up number 3, because as I said, we'll start class seeing what you got for your answer. Any questions, as always, please send me a reminder. Have a good night.